Hi everyone, so in this video I'm going to discuss the TCA cycle. So in the past video I talked about glycolysis and pyruvate processing, so if you're confused on how we got to this point, I would really recommend watching that video first. So overall, what's been happening so far, we've gotten some energy from glycolysis, we've made pyruvate, we've processed it to acetyl-CoA, now we're inside the matrix, and we're ready for the TCA cycle. So the TCA cycle actually gets quite a bit of energy out in terms of electron carriers. So yeah, let's just go through it. So basically, the main idea of what we need to know is that it's just a cycle of a bunch of different reactions that are all basically working towards oxidizing acetyl-CoA and getting as much of electron power out of that molecule as possible. And so overall TCA, it's happening in the mitochondrial matrix. And overall, what we're getting is we get, I don't know if you have to know these specific numbers, but overall you get 3 NADH produced and 1 FADH2, which FADH2 is really just like another electron carrier. We haven't seen it in the previous steps of cellular respiration, but it's really similar to NADH in its function here. We also get 1 ATP. Technically, it was made as a GTP first, but it's interconverted from GTP to ATP very easily, so we'll just say that it's making an ATP. And remember again that this is made through substrate level phosphorylation, so we still haven't done oxidative phosphorylation yet. That's in the last step with the electron transport chain. So this is made through substrate level phosphorylation, like the ATP in that we're making in glycolysis. And we also, I believe, we release 2 CO2 molecules. So this is really telling you that we're releasing a very oxidized form of carbon, so we are actually reducing a lot of other things because something is being oxidized. So that's just a good indication. If you see something that's very oxidized, you know that something else is being reduced. And we also know that because CO2 is the most oxidized form of carbon, and we've run through this cycle, we've now gotten a huge amount of electron energy out of glucose from when we first started. And so this is the overall sort of what's happening. You really don't need to know the details of this cycle, but I will draw the input and output diagram just to make this more clear. And again, just a reminder that we do want to indicate all our substrates with solid lines, and then all of our high energy intermediates or products with dotted lines, as I just draw a solid line. So again, we're inputting FAD, and we can get FADH2 out, and we're also getting an ATP out, and we're putting in NAD plus and NADH out. So we've made a little bit of ATP. It's really not much, but we haven't really made a lot up to this point anyways. But we're actually getting a decent amount of electron carriers made. And remember that a TCA cycle is running on 1 acetyl-CoA. So if I'll just draw an overview here. So 1 glucose molecule makes 2 pyruvate molecules. So this is through glycolysis. And then 2 pyruvate will make 2 acetyl-CoA through pyruvate processing. And then we can think of if each acetyl-CoA is doing a TCA cycle, then from each one we're getting the 3 NADH, 1 FADH2, 1 ATP, 2 CO2. So that's times 2 in the sense that you're getting that from each cycle. So from 1 glucose molecule, up here we had a net 2 ATP, 2 NADH, And then in pyruvate processing, we make 1 NADH per pyruvate. So overall, we're going to get 2 NADH per 1 glucose, because 1 glucose gives 2 pyruvate molecules, and each pyruvate molecule gives us 1 NADH at this step at pyruvate processing. And then if we enter the TCA cycle, we're going to get 3 NADH, 1 FADH2, 1 ATP, and 2 CO2 molecules for every cycle. So we multiply each number by 2 to get what we're actually getting from 1 full glucose molecule going through all of these steps. I don't think you really need to know specific numbers, but just like for completion, it's nice to just go through this to get a sense of what the numbers are looking like right now, because the output for oxidative phosphorylation is just so huge. So it really gives you an idea of how much energy the electron carriers actually have in terms of ability to make ATP. So hopefully this gave you a good idea of what's going on in the TCA cycle. And then, yeah, in my next video, I'll go through the electron transport chain and all of the oxidative phosphorylation stuff.